The Dart's nose dropped. The wild rotation ceased. The aircraft, as if offended by its own undignified predicament, simply flew. It recovered to stable, level flight all on its own. With the throttles likely set near idle for the spin recovery attempts, the mighty J-75 engine continued to purr. The F-106, pilotless but perfectly trim, became a ghost ship. Witnesses on the ground, including Faust as he floated down under his parachute, stared in disbelief. The sleek gray jet was now cruising peacefully, a silent, autonomous sentinel gliding across the big sky. It began a slow, shallow descent, its engines still providing power. It flew for nearly 50 miles, a mechanical phoenix refusing to die. It finally touched down in a snow-covered wheat field near the town of Big Sandy, Montana. Without landing gear, which Faust had not lowered and the aircraft had no way to deploy, it settled onto its belly in a remarkably gentle, almost dainty slide. It came to rest, engine still running as if waiting for its pilot to catch up. The only significant damage was a bent intake lip and scraped underside paint. The landing was so smooth that investigators later found the gun sight reticle still perfectly centered in the cockpit glass. The Air Force, astonished, recovered the aircraft. They christened it with the immortal nickname, the Cornfield Bomber. They repaired it, gave it a fresh coat of paint, and returned it to active service. For years afterward, 580787 flew with a small, proud decal below the cockpit, a cartoon of a parachute, and the words, "The Cornfield Bomber." Captain Faust, after his harrowing experience and surreal walkaway landing, went on to fly the very same aircraft again. The F-106 that had ejected its pilot had not only saved itself, but had performed the world's most improbable unmanned landing. It was the ultimate expression of the Dart's contradictory nature, utterly unforgiving one moment, miraculously resilient the next. For all its world-beating speed, its revolutionary systems, and its apocalyptic nuclear armament, the operational history of the F-106 Delta Dart is one of profound, almost eerie quiet. It was a weapon built for a war that never came. Across 3 decades of service, from the brink of the Cuban Missile Crisis to the twilight of the Cold War in the late 1980s, no F-106 ever fired a missile in anger. It never intercepted a hostile bomber over North America. It never unleashed its Genie rocket. Its career was spent not in combat, but in the endless pressurized rehearsal for it. The Dart's life was a ritual of vigilance. Its days were filled with relentless training sorties, scrambling from alert shelters at the sound of a klaxon, streaking skyward to intercept practice targets, often converted drones like the QF-100 or other U.S. aircraft playing the role of Soviet intruders. It would screen to the limits of its performance envelope, run through intercept solutions, and simulate launches. It was a constant test of readiness, a muscle memory of apocalypse. It also served as a sentinel. Throughout the 1960s and 70s, Soviet long-range reconnaissance aircraft like the Tu-95RT Bear-D would probe the edges of North American airspace, testing defenses and gathering electronic intelligence. The Dart, with its blistering speed, was often the chosen platform to escort these intruders, a polite term for a hypersonic intercept that served as a clear, visual message of capability. A pilot would slide his Dart alongside the hulking, prop-driven Bear, close enough to see the other crew's faces, a display of technological dominance before peeling away in a thunderous sonic boom. The aircraft set records, pushing the boundaries of altitude and speed for its class. It became a staple at air shows, where its sleek, futuristic shape and thunderous performance thrilled crowds, a public symbol of American air supremacy. But within the squadrons, its relationship with pilots remained complex. They respected its power, but distrusted its automation. They marveled at its speed, but lamented its weaponry. The joke persisted. The F-106 was the world's fastest, most advanced interceptor, as long as you never actually had to shoot anything. By the 1980s, the strategic landscape had shifted irrevocably. The threat was no longer waves of lumbering bombers, but swarms of low-flying supersonic cruise missiles and the ever-present specter of intercontinental ballistic missiles, against which interceptors were useless. The multi-role fighter, aircraft like the F-15 Eagle and F-16 Fighting Falcon, had ascended. These planes could do it all: air superiority, interception, ground attack. The era of a single-purpose, ground-controlled, dedicated interceptor was over. The F-106, for all its specialized genius, had no place in this new, flexible order. It was a masterpiece of a forgotten art. The retirement of the F-106 Delta Dark was not marked by ceremony for a victorious warrior, but the quiet, practical dismantling of a system. Some were converted to QF-106 target drones, their final fate to be shot down by the very multi-role fighters that replaced them, a poignant, if not ignoble end. Others were dispersed to museums and airbase gates, where they sit as static displays, their sharp lines still hinting at the speed they once commanded. And one, serial number 580787, resides in the National Museum of the United States Air Force in Dayton, Ohio. It is displayed not just as any aircraft, but as the Cornfield Bomber, its unique story ensuring its immortality. The F-106 never fought a war. It never claimed to kill. In the ledger of combat, its pages are blank. Yet its legacy is profound. It represents a specific, white-hot moment in the Cold War, a peak of focused, paranoid engineering. It was born from a time when the fear was so palpable, the timeline for response so compressed, that a nation was willing to spend billions to shave minutes off an interception timeline. The philosophy was pure, brutal calculus. Seconds saved over the Arctic might mean lives saved over Detroit. In this context, the F-106's flaws, the faltering missiles, the glitchy computer, were not mere engineering failures, they were the acceptable trade-offs for that one non-negotiable requirement: speed. Raw, unadulterated, physics-defying speed. It was a jet that could escape its own weapons, a paradox that perfectly encapsulated the era's breakneck technological race. It was a system that tried to remove the human from the loop, only to prove that the human was still the most reliable and most fallible component. It was a machine so well built that even when abandoned, it could find its own way home. The F-106 Delta Dart couldn't outrun the future. The future was multi-role, flexible, digital. The Dart was analog, specialized, and single-minded. But for a generation, it was the sharpest tip of the spear, a silent, screaming promise held against the northern sky. It was America's fastest answer to the question of Armageddon, a question it thankfully never had to answer. But this carefully orchestrated arsenal ran headlong into the F-106's defining characteristic, its blistering, world-bending speed. The Dart didn't just fly fast, it existed in a velocity regime that was still new and poorly understood. Engineers discovered a terrifying paradox. The Interceptor was so phenomenally quick, it could outrun its own weapons. The issue was one of relative velocity and aerodynamic stress. When a pilot, guided by the MA-1 system, initiated a missile launch sequence, the weapons bay doors would slam open. The Falcon missile would be ejected into the 1,500-mile-per-hour slipstream by a piston. In that instant, the missile, designed for launch from slower aircraft, was subjected to a shock it was never meant to survive. Imagine throwing a dart from the window of a speeding bullet train. The turbulence is chaotic and violent. Test flights and early operational deployments revealed a catalog of failures. Falcons would leave the bay only to immediately stall aerodynamically, tumbling uselessly away as the dart streaked past. Their delicate guidance fins, meant to make subtle course corrections, could be ripped off by the sheer force of the slipstream. Even if they survived the launch, their own rocket motors, designed to accelerate them toward a target, often couldn't close the gap on a dart that was still accelerating in afterburner. The Interceptor would literally leave its missiles in the dust, a supremely fast courier dropping packages it had already outrun. The infrared-seeking variants faced another problem: the intense heat of the Dart's own engine and the skin friction at Mach 2 could overwhelm their sensors, causing them to lock on to their own launch aircraft, a phenomenon that led to immediate, panicked jettisoning of the weapon. Pilots developed a gallows humor about it. They'd return from a training intercept, their instruments showing a perfect system performance, only to be told by range controllers that their Falcons had fluttered to the ground like wounded birds miles behind them. The analogy was perfect, if horrifying. It was like flooring a dragster so violently that the bullets fired from its hood-mounted machine gun simply fall onto the track behind it. The very speed that was the Dart's reason for being had rendered its primary weapon system nearly impotent. It was a sword that could outrun its own thrust. If the weapon system was a failure of physics, the Dart's brain was a failure of overambition. The semi-automatic ground environment, SAGE, was the most expensive and complex military computer network in the world at the time. Its nerve centers were enormous, hardened concrete blockhouses filled with whirring magnetic tape drives, banks of vacuum tubes that glowed with the heat of a small factory, and massive IBM AN FSQ-7 computers that each weighed 250 tons and required 3,000 kilowatts of power, enough to run a small town. SAGE was meant to be the unblinking eye and the unerring hand of North American air defense, processing radar data from Texas to Greenland and automatically directing interceptors to their targets. The F-106 was designed from the rivets up to be SAGE's perfect airborne instrument. Its Hughes MA-1 fire control system wasn't just a targeting computer, it was an autopilot on steroids. The revolutionary, and to many pilots terrifying concept was this: once the Dart was airborne and the pilot had switched to SAGE mode, a ground controller could take over. The massive computers on the ground, tracking both the enemy bombers and the interceptor, would calculate the optimal intercept course. This course, a stream of digital commands, would then be transmitted via secure data link directly to the MA-1 in the aircraft. Once received, the MA-1 would simply fly the plane. It would command the throttles, adjust the control surfaces, and execute climbs, turns, and descents with a precision no human pilot could match, all to place the F-106 at the exact point in space and time for a missile launch. The pilot's role was reduced to that of a systems monitor, a biological backup. He was to watch the scopes, ensure the missiles were ready, and pull the trigger when the computer told him to. He was in the most literal sense a passenger in his own weapon system. The future had arrived, and it had rendered the fighter pilot an auditor. In practice, SAGE and the MA-1 were a chronicle of gremlins, glitches, and near catastrophes. The technology was simply too far ahead of its time. The data links were prone to static and dropouts. A lost signal could cause the MA-1 to freeze or default to a pre-programmed and often disastrous failsafe mode. Pilots swapped horror stories that became legend. There was the Dart that, upon receiving a SAGE command, abruptly executed a perfect, precise, and uncommanded roll onto its back and began a screaming dive toward the Earth, the MA-1 dutifully following some ghost in its machine. The pilot had to physically fight the controls, disengaging the system with a sharp, panicked yank on the manual override. Another interceptor, flying over the featureless Canadian tundra, had its MA-1 decide the optimal intercept path was through the ground, initiating a descent that was only arrested when the pilot, seeing his altimeter unwind with insane speed, took back control a few thousand feet from becoming a crater. The system's calculations, for all their vacuum tube complexity, were brittle. They assumed perfect data and predictable bomber behavior. A Soviet bomber taking an unexpected evasive turn or a simple error in radar altitude input could cause SAGE to generate an intercept solution that was physically impossible, ordering the dart into a turn that would black out the pilot or exceed the aircraft's structural limits. The pilots, a breed of men used to sovereignty in the cockpit, chafed under this electronic overseer. They derisively coined their own acronym for SAGE, Suddenly Aircraft Goes Elsewhere. It was a joke born of profound unease. Their $5 million Mach 2 death dart could be hijacked by a hiccup in a magnetic tape drive 100 miles away, turning the most advanced interceptor in the world into a runaway train. The promise of automated, flawless interception had crashed into the messy reality of unreliable 1950s computing, creating a machine that was simultaneously too smart for its own good and not nearly smart enough to be trusted. The F-106 was a masterpiece of aerodynamics enslaved to a temperamental and often incompetent electronic brain. The F-106's service history is a chronicle of the bizarre, a testament to a machine whose behavior often defied both logic and the expectations of its designers. It was a temperamental thoroughbred, capable of breathtaking performance and bewildering failure in equal measure. But of all the strange tales whispered in officers' clubs and maintenance hangars, one stands alone, not merely as an incident, but nearly as a mythological event that seemed to confirm the dart had a mind of its own. It happened on a cold, clear February day in 1970 over the vast frozen expanses of Montana. Captain Gary Faust, an experienced fighter with the 71st Fighter Interceptor Squadron based at Malmstrom Air Force Base, was conducting a routine Air Combat Maneuvering, or ACM, training mission. His F-106A, serial number 580787, was clean, no external fuel tanks, just the pure, unadulterated airframe. He was practicing aggressive high-G maneuvers, pushing himself and the jet to their limits. During one particularly violent maneuver, a combination of factors, pilot-induced oscillation, the Delta Dart's tricky low-speed handling characteristics, and a sudden loss of situational awareness, conspired to put the aircraft into a flat spin. A spin in a high-performance jet is one of aviation's direst emergencies. It is a stabilized auto-rotational descent where the aircraft corkscrews toward the ground, its controls often rendered useless. Recovery procedures are complex and require altitude, lots of it. Captain Faust fought the controls, executing the prescribed spin recovery drills with calm precision, but the spin deepened. The flat, brutal rotation of the Montana landscape outside his canopy told him he was losing the battle. At 15,000 feet, with the earth rushing up and no recovery in sight, he reached for the last resort. He pulled the ejection seat face curtain, a canvas blind that, when yanked, triggers a sequence of explosive events. With a roar of rockets and a violent kick in the back, Faust was blasted clear of the stricken aircraft. The canopy blew, the seat rails fired, and in an instant he was tumbling in the freezing slipstream, watching his multi-million-dollar interceptor spiral away, seemingly doomed to impact in a fiery crater. But then something impossible happened. As Faust's weight left the cockpit, as the seat's separation charge freed him from the aircraft, the center of gravity of the F-106 shifted dramatically. At the same moment, the violent aerodynamic disruption caused by the ejection and the now open cockpit likely altered the airflow over the airframe. The spin, which had been sustained by a specific balance of forces, broke. The early 1950s dawned not with the hopeful light of a new decade, but with the cold, creeping dread of a new kind of vulnerability. The Iron Curtain had fallen across Europe, and across the vast, frozen expanse of the Arctic, a new and terrifying front line was drawn in the thin, frigid air. Soviet strategic bombing doctrine, once a theoretical exercise, was now being forged into steel and fueled by potent, high-octane paranoia. The threat took the form of two formidable propeller-driven behemoths, the Tu-95 Bear, its 8 massive counter-rotating propellers producing a distinctive earth-shaking thrum that could be detected by submerged sonar arrays, and the newer, sleeker Myasachev M4 Bison, a swept-wing jet bomber with the range to strike deep into the American heartland. For the commanders of the newly formed United States Air Force and for the civilian planners of the Continental Air Defense Command, CONAD, this presented an existential calculus of terror. The Arctic was not a barrier, it was a highway. The vast, sparsely populated stretches of Canada offered little in the way of early warning. The Soviet bombers, lumbering though they might seem, only needed to get through once. One bomber slipping through the net could deliver a city-killing payload on Chicago, Detroit, or Washington, D.C. The doctrine of massive retaliation meant little if the first warning of war was the flash of a nuclear detonation over Pittsburgh. The existing interceptors, the F-89 Scorpion, the F-94 Starfire, even the formidable F-101 Voodoo were seen as stopgaps. They were fast, but not fast enough. They could climb, but not with the blistering, sky-rending urgency the scenario demanded. What was required was not merely an evolution, but a revolution. The Air Force didn't need a better fighter. It needed a dedicated, single-purpose weapons system. It needed a machine that lived and breathed one mission: get airborne, climb to the edge of space at a rate that defied human endurance, locate the incoming bomber swarm, and destroy it with overwhelming force, all within minutes. It needed, in essence, a surface-to-air missile with a man in it. This panic, this urgent billion-dollar anxiety was the crucible in which the F-106 Delta Dart was forged. From the outset, it was conceived not as an aircraft in the traditional sense, but as a component in a vast semi-automated defense network known as the Semi-Automatic Ground Environment, SAGE. The pilot was not a knight in aerial combat. He was the final biological failsafe in a chain of command that began with distant radar picket ships and ground-based early warning stations. His cockpit would be a womb of analog computers and glowing scopes fed data from the ground. His plane would be an extension of the network itself, and it would have to fly faster, higher, and with more brutal purpose than anything that had ever worn the star and bar roundel. From this towering ambition would emerge one of the most breathtakingly capable yet profoundly troubled aircraft ever to slice through the stratosphere, a jet so fast it would outpace the very weapons it was built to fire. To look upon the F-106 Delta Dart, even today, is to witness the pure, unadulterated geometry of speed. It was a weapon stripped of all compromise, a study in ruthless aerodynamic efficiency. Its form was a single coherent idea given shape in aluminum and titanium, a dart. A long, needle-like fuselage, sharp enough to pierce the sound barrier with minimal resistance, culminated in a cockpit canopy that was itself a seamless teardrop extension of the fuselage line. From the midsection, a vast, razor-thin delta wing swept back in a perfect, unbroken triangle, its leading edges so sharp they appeared capable of cutting the sky itself. There were no clumsy curves, no extraneous bulges for guns, initially, no traditional tail. Vertical stabilizers were small, almost an afterthought. This was an aircraft that looked as if it were already moving at Mach 2 while sitting perfectly still on the tarmac. At its heart roared the Pratt & Whitney J75 P-17, an afterburning turbojet of almost unimaginable fury for its time. In full military power, it generated over 24,500 pounds of thrust, a force that could shove the 40,000-pound airframe through the air with the violence of a cannon shot. The engine was the Dart's soul, and the airframe was its willing, if sometimes protesting, vessel. The speeds it demanded pushed 1950s metallurgy and engineering to its absolute limit. At Mach 2.3, approximately 2,450 kilometers per hour, or over 1,500 miles per hour, the very skin of the aircraft would heat up from friction to temperatures that could burn a careless hand. The thin delta wings, while superb for high-speed flight and providing immense internal fuel volume, were treacherous at low speeds, offering little lift and demanding a landing approach so fast it bordered on controlled terror. Pilots joked, darkly, that the F-106 didn't so much land as arrive at the runway. But this punishing performance was all in service of that one sacred obsession, the intercept. The F-106 was a sprinter, not a marathon runner. Its entire being was optimized for a single explosive performance, a maximum power takeoff, a near vertical zoom climb to altitudes above 50,000 feet, a supersonic dash to a pre-calculated kill box, and the launch of its armament. It carried an internal weapons bay, not for bombs, but for a sophisticated arsenal of air-to-air missiles, primarily the IM-4 Falcon and the nuclear-tipped AIR-2 Genie. Its Hughes MA-1 fire control system was a marvel of its age, designed to integrate seamlessly with Sage ground control. A ground controller could literally fly the aircraft via data link to an optimal firing position, with the pilot acting as a systems monitor and final executioner. This automation birthed the Dart's infamous nickname, the missile with a man in it. The pilot was not there for dogfighting agility. The F-106, with its high wing loading and focus on straight-line speed, would have been a lumbering duck in a turning fight with a MiG. He was there because in the chaotic, electronic fog of war, a human brain was still deemed the best judge for that final, irrevocable decision to fire. Yet his role was profoundly different from that of a pilot in a Mustang or a Sabre. He was a systems operator, strapped into the apex of a technological spear, hurtling toward a destiny calculated by vacuum tubes and radar pulses. The plane didn't just break speed records, it broke the very concept of what it meant to be a fighter pilot. It was a machine that shouldn't have worked, built for a mission no one ever wanted to fly, and its greatest enemy would soon prove to be not Soviet bombers, but the terrifying, paradoxical physics of its own unparalleled performance. Part 3. The Missile Bay Disaster. Concealed within the F-106's sleek fuselage, behind hydraulically actuated doors that snapped shut with a sound like a bank vault ceiling, was its clenched fist, its internal weapons bay. This was a feature borrowed from bomber design, a necessity to preserve the Dart's sacred drag-free profile. Opening bomb bay doors on a supersonic aircraft was an invitation to catastrophic buffeting and structural failure. The Dart system was designed to cycle with swift, brutal efficiency. Within this bay resided not iron bombs, but the cutting-edge and deeply flawed air-to-air arsenal of the late 1950s. The primary armament was a quartet of Hughes IM-4 Falcons. These were not the agile dogfighting sidewinders of later eras. The Falcon was a complex radar or infrared-guided missile designed for a single specific task, destroying large, non-maneuvering strategic bombers. They were temperamental, requiring extensive pre-cooling of their seeker heads before launch, and their reliability was a constant source of anxiety. Alongside them, nestled in the center of the bay like a deadly fat cigar, was the McDonnell Douglas AIR-2 Genie. This was not a guided missile at all. It was an unguided rocket, a simple solid-fuel motor with a fearsome payload, a W-25 warhead with a yield of 1.5 kilotons. The tactical doctrine behind the Genie was a chilling reflection of Cold War logic. If a formation of Soviet bombers was too dense, too close to its target, or simply too elusive for conventional missiles, the Interceptor pilot's solution was to fire the Genie into the midst of the formation and detonate it. It was the ultimate area denial weapon. The plan, baldly stated, was if you can't hit the bomber, nuke the patch of sky it's flying through.